In section 1.1, we'll look at linear equations and rational equations. First up is solving linear equations in one variable. We have the definition of a linear equation in one variable. It's an equation that can be written in the form ax plus b equals 0, where a and b are real numbers a is not equal to 0, and x is the variable. An equation that can be written in the form ax plus b equals 0, where a and b are real numbers, a is not equal to 0, and x is the variable. In example 1, we need to determine if the following equations are linear equations in one variable or not. Example A, 8x minus 6 equals 0. That is in the form of ax plus b equals 0. So the answer is yes. B, x squared minus 9. This is not a linear equation because of the x squared. C, 5x plus 8 equals 3x minus 12. This one is a linear equation in one variable. We can move some stuff around and get 2x plus 20 equals 0. So it satisfies the form ax plus b equals 0. Part D, 3 over x plus 8 equals negative 1. This is not a linear equation. 3 over x, if you use the rules of exponents, that's actually equal to 3 times x to the negative 1. And then lastly, part E, 7x minus 3. This is not a linear equation. It's not an equation at all. It doesn't have an equal sign, so it's not a linear equation. Next, let's look at some tips for solving linear equations in one variable. Step 1, simplify both sides of the equation using distribution, combining like terms, and clearing out denominators. Step 2, move terms with the variable to one side. We usually move that to the left side, and then move the constant terms, the numbers, to the other side, which is usually the right side. Step 3, multiply or divide by the same quantity on both sides of the equation to make the coefficient of the variable equal to 1. And then step 4 is write the answer as a solution set. Let's look at example 2. Solve for x. 2 times 3x minus 5 plus 8x is equal to x minus 9. The first step in solving this equation, I'm going to distribute the 2. So 2 distributes to the 3x, and it distributes to the 5. And then simplify. 2 times 3x is 6x. 2 times 5 is 10. Everything else is the same. And now, let's simplify the left side. 6x plus 8x is 14x. Everything else remains the same. Now I'm going to move all of the x's to the left. I have 1x on the right side. When that moves over, it moves over as negative x. 14x minus 1x is 13x. the negative 10 on the left side will move over to the right side. It moves over as a positive. So positive 10 minus 9 is 1. And now divide both sides by the coefficient of the x, and we get x is equal to 1/13. And we will write the following. The solution set is 1/13. In this textbook, we write the answers to equations, the solutions, we write those as a set. And to be a set, we just include the numbers inside these curly braces. Example 3, solve for p. P plus 5 over 2 minus p minus 1 over 3 is equal to p over 5 minus 3. To solve an equation that has denominators, one thing that we'll do is clear out denominators. We do that by multiplying both sides of the equation by the least common denominator. The least common denominator for this equation is simply the product of all three of these denominators, 2 times 3 times 5. And we know this because 2, 3, and 5 do not share any common factors, so the common denominator is the least common denominator. And that's 30. We're going to multiply both sides of the equation by 30. So 30 times p plus 5 over 2 minus p minus 1 over 3, that's the left side, times 30 times p over 5 minus 3. Next, I want to distribute the 30 to each of the two parts on both sides. This would be 30 times p plus 5 over 2 minus 30 times p minus 1 over 3 is equal to 30 times p minus 5, p over 5 rather, minus 30 times 3. Next, we simplify the denominators by canceling with the 30s. If you've used the least common denominator correctly, you should have no more fractions after this step. In the expression on the left, 30 divided by 2 is 15. So we have 15 times p plus 5. Next, we have 30 divided by 3. That's 10. So we have negative 10 times p minus 1. On the right side, 30 divided by 5 is 6. So we have 6p. And lastly, 30 times 3 is 90. Next, I'll distribute the 15 and the 10. So we get 15p plus 75 minus 10 times p plus 10 is equal to 6p minus 90. I'm going to combine like terms on the left. I have 15p minus 10p. That gives me 5p. 75 plus 10 is 85. The right side stays the same. 6p minus 90. Next, I'll move the p terms to the left and the constant terms to the right. 6p moves to the left as minus 6p. So we have 5p minus 6p is negative p. 85 on the left moves to the right as negative 85. That gives me negative 175. And then divide both sides by negative 1. we get P is equal to 175, and the solution set is the set 175. Let's look at the next page in example 4. Residents pay a monthly service fee of $14.50 plus 8 cents per kilowatt hour used for electricity. The equation for a person's monthly bill is C equals 0.08 W plus 14.50, where W is the amount of electricity used in kilowatt hours. 1 month, Bob paid $145.66 for electricity. How many kilowatt hours did he use? So let's start with the equation for electricity usage and the cost. C is equal to 0.08 W plus 14.50. Bob paid $145.66. So that is the value of C. That's the cost for electricity for that month. We are looking for how many kilowatt hours, and we know that this is represented by W in the equation, so we need to solve for W. First, I'm going to move 1450 to the left side. When I subtract that from 145.66, I get 131.16. That is equal to 0.08 W. To solve for W, we divide by the coefficient of W. That is 0.08. And using the calculator, 131.16 divided by 0.08 gives me 1,639.5 kilowatt hours. In the next section, we discuss conditional equations, identities, and contradictions. A conditional equation is an equation that is true for some values of the variable but false for other values. An identity is an equation that is true for all values of the variable where it is defined. And a contradiction is an equation that is false for all values of the variable. Let's look at some examples of conditional equations, identities, and contradictions. Next page. Example 5. Determine if each equation is a conditional equation, identity, or contradiction. Then give the solution set. So in example A, we have 5x minus 10 is equal to 5 times x minus 2. The left side stays the same. I'm going to distribute the 5 on the right side. And we get 5x minus 10 is equal to 5x minus 10. If I move the 5x to the left, it cancels, gives me a 0. And if I move the negative 10 from the left to the right, that cancels with the other negative 10, gives me a 0. 0 is equal to 0, so this is true. And since there are no other variables, there's nothing to solve for, this is just true for all x. And so this is an identity. So which values of x will this work for? This works for all values of x. And when we have that situation, we say that the solution set, I'll abbreviate the word solution from here on out, the solution set is, and we either use this fancy math symbol, the R with the double bar on the left, and that stands for all real numbers. Later on, it'll also be appropriate to use interval notation, which would be negative infinity to infinity. Example B, we have x plus 2x minus 3 plus 4x equals 5x minus 6. I'm going to combine the x's on the left side. I have 1x plus 2x plus 4x. That is 7x minus 3 is equal to 5x minus 6. Next, we move all of the x's from the right to the left. We have 7x minus 5x is 2x. And then we move negative 3 from the left to the right. Negative 6 plus 3 is negative 3. Divide both sides by 2, and we get x is equal to negative 3 halves. So this equation is true if x is equal to negative 3 halves. If x is any other value, then the equation is not true. So that is a conditional equation. It is true on the condition that x is negative 3 halves. That is the only value that works. The solution set is the set negative 3 halves. Let's look at example C. 3x plus 4 is equal to 2 times x minus 1 plus x. First, we start by distributing the 2. So we get 3x plus 4 on the left is equal to 2x minus 2 plus x on the right. I'm going to combine the x's on the right side together. The left side stays the same. 3x plus 4 is equal to 3x minus 2. Now if I move the 3x from the right side to the left side, it cancels with the other 3x. So the x's are all gone. They cancel. And I'm left with 4 is equal to negative 2, which is false. And this is false for all x. So therefore we have a contradiction. The contradiction means that there are no values of x that will satisfy the equation. And so the solution set is what we call the empty set. There are two symbols for the empty set. You just have a set that has nothing in it. It is empty. It has nothing. Or the circle with a slash through it is also the empty set. So as a side note, little warning, it is not the set of the empty set. That is not a representation of the empty set, so don't use that. Next, we look at solving rational equations. To solve rational equations, first we want to clear denominators by multiplying both sides of the equation by the least common denominator. Then we'll solve the linear equation that is left over. Finally, because there may be variables in the denominator, we should check our answers against the restricted values. First off, let's talk about the restricted values in example 6. We want to solve for x. 15 over x is equal to 3 over x plus 4. To find the restricted values, these are values that we cannot end up with as a solution. We set the denominator equal to 0 and solve. And whatever solutions we get, those are the restricted values. This first example is fairly straightforward. The denominator is x. We set that equal to 0. That's already solved. So our restricted value is x equals 0. We just have to keep in mind that we cannot end up with a solution of x equals 0 at the end. To solve this equation, we need to first come up with the LCD. Again, the only denominator we have is x, so the LCD is x. I'm going to multiply both sides of the equation by x. So we have x times 15 over x is equal to x times 3 over x plus 4. I'm going to distribute the x on the right side, so I'll leave the left side alone for now. We get x times 3 over x plus x times 4 is 4x. And now we cancel the denominators. X divided by x cancels on the left, so that's 15. X divided by x on the right side also cancels. That's a 3 plus 4x. Moving the 3 to the other side, we get 12 is equal to 4x. Divide both sides by 4, and we get x is equal to 3. 3 is not one of the restricted values, so we put that in the solution set. The solution set is the set 3. Let's look at example 7. We want to solve for m. 4 over m minus 4 is equal to 3 over m plus 1 plus 2 over m squared minus 3m minus 4. To help us find the restricted values, the first thing I'm going to do is factor the quadratic in the right side here. So m squared minus 3m minus 4, that factors as m minus 4 times m plus 1. And that's also the two denominators from the other parts of the fraction. We're going to set this equal to 0 to find our restricted values. When you set an expression that has multiple factors, here we have two factors, m minus 4 and m plus 1. When you set that equal to 0 and you want to solve, you just split it up along its factors and set each of the factors equal to 0. So m minus 4 equals 0, and m plus 1 is equal to 0. The restricted values are m equals 4 and m equals negative 1. Again, remember that at the end we cannot have m equals 4 or m equals negative 1 as a solution to the problem. Let's look for the LCD. We have the two factors from the right side quadratic. And then if we look at the other two fractions, those denominators are already present in just the LCD that we already have, m minus 4 and m plus 1. So m minus 4 times m plus 1, that's our LCD. We're going to multiply both sides of the equation by the LCD. Next, I need to distribute the terms on the right, so I'll leave the left side alone for now. On the right side, we get m minus 4 times m plus 1 times 3 over m plus 1 plus m minus 4 times m plus 1 times 2 over m minus 4 times m plus 1. And next, we cancel the denominators with our LCD pieces. On the left side, I have m minus 4. That part cancels. The first piece on the right side, I have m plus 1. So that's going to cancel. And on the second piece on the right side, I have both of them. I have both m minus 4, that cancels, and m plus 1 cancels. So let's write what we have left over. We have 4 times m plus 1 is equal to 3 times m minus 4 plus 2. So clearing out denominators definitely helps. Next, I'll distribute the 4 and the 3. We have 4m plus 4 is equal to 3m minus 12 plus 2. Let me combine the numbers on the right side. I have 4m plus 4 equals 3m minus 10. Moving the 3m to the left, I get m. And moving the 4 to the right, I get negative 14. Checking this solution against the restricted values, everything is okay. And so the solution set is the set negative 14. Let's look at example 8 on the next page. We want to solve for Q, and the equation is A equals MQ minus ST. This is an important type problem because many times you'll have a formula, whether it's a geometric formula or a formula from physics, and you need to solve for one of the variables sort of in the middle. This is where this skill would come into place. So let me start by writing the equation. We're looking to solve for Q. So the first thing is I'm going to move the quantity that is S times T. I'm going to move that to the left side. I got to get it away from where the Q is. It comes over as a positive. So we have A plus ST is equal to MQ. And now to solve for Q, I see that it's being multiplied by M. To get rid of the M, I'll just divide by it. We divide both sides. And we get Q is equal to A plus ST divided by M. And the solution set for Q is the set of A plus ST over M.